Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 47, Liquids and Solids, Part 2. Here are our objectives for today's video. Pause here. So last video, we talked about identifying intermolecular forces. In this video, we're going to be talking about comparing intermolecular forces. So the first thing we need to understand is how to compare London dispersion forces. This first bullet point here is really just a reminder, but it's going to be really, really important for this entire video, so I wanted to include it as a separate point. Hydrocarbons are just any combination of hydrogen and carbon. Anytime you have an HC combination, it means the only type of intermolecular force is London dispersion force. And then the second point, the more electrons, or sometimes you'll hear me say it with molar mass because it's a more or less linear relationship. The more electrons something has, the more polarizable the electron cloud and the higher the London dispersion force. Pause here. All right, I will say these answers out loud. For the first one, it is CH2Cl2. There are two different explanations that are correct for it. The first explanation is that CH2Cl2 has a higher molar mass or higher number of electrons than CH2. Therefore, it has higher London dispersion forces and will have the higher boiling point. The second explanation would be that CH2Cl2 has dipole-dipole interactions, which is a stronger intermolecular force at comparable molar mass to CH4, and therefore will have the higher intermolecular forces and therefore the higher boiling point. The second one, it is NGS. So these are on the same row of the periodic table, so the sizes are more or less comparable. But MGS has a +2 -2 as opposed to NaCl, which has a +1 -1. So the MGS is held together with more force and therefore will have the higher boiling point. The third one, that is I2, there's one explanation for that, and that is that I2 has a higher molar mass or a higher number of electrons in Br2. Therefore, it has a more polarizable electron cloud and has higher London dispersion forces. Pause here. So sometimes those explanations that we use for the last example don't necessarily explain everything. So there's one other factor that can affect London dispersion forces, and it specifically applies to hydrocarbons. So when we have a branch versus a linear. So in these two pictures, the one on the right, isobutane, that is branched, as opposed to butane, which is linear. It's just a line of carbon atoms with hydrogens around it, whereas with butane, the carbon is not in a line. Linear hydrocarbons tend to be more polarizable than branched hydrocarbons at comparable molar mass. Butane and isobutane are very, very similar in molar masses, but they will have a difference in boiling point. Pause here, you do not need to draw a picture. So this is something that isn't going to pop up too much, but I just wanted for you to have seen it. So you can sometimes have ion-induced dipole forces, where an ion can either induce a temporary dipole in a nonpolar atom. So that's what's going on in the left. The chlorine is inducing a dipole in hexane, or it could actually cause things to rearrange around them. That's really, really common to see happen with water. I'll probably show you guys a picture of that during class, but the image on the right is showing that. Whereas if you have an anion next to a polar molecule, the polar molecule will arrange such that its partial positive end is close to the anion, or if there's a cation, the partial negative end will be near it. Pause here. So this is just a general review. This is just really, really important to remember. If you have high intermolecular forces, you will have high boiling point, high melting point, low vapor pressure. Low vapor pressure because it is more difficult for something to go from the liquid to the gas phase. Just as a reminder, vapor pressure is the pressure directly above the surface of a liquid that is a result of the fact that there's always some of that liquid going into the gas phase. Pause here. So the one with the higher vapor pressure will be the one with the lower intermolecular forces, which in this case is going to be isobutane. Even though these have comparable molar masses, they both have London dispersion forces. Isobutane is branched compared to butane, which is linear. Isobutane has a less polarizable electron cloud and therefore has lower intermolecular forces, which will lead to it having a higher vapor pressure. Thank you so much for watching and have a great night.